Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 12 of electronics, in which I'm going to discuss clamper and also voltage multiplier. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started guys. Meanwhile, just let me check whether I'm audible or not, then I'll proceed further. Okay, so let's get started. Yes, I'm audible, so I'll proceed further. Okay, okay guys. So clamper circuit. Okay, clamper clamper circuit. Clamper circuit. Clamper circuit. Okay, so what is clamper circuit? What clamper does? Okay, so this shifts shifts the waveform. Okay, waveform. So clamper shifts the waveform. We have studied clipper, right? That clips the waveform. Okay, in similar way, the clamper circuit that shifts the waveform. Okay, so this is going to shift the waveform. Okay, and clamper is combination of diode plus resistor plus capacitor. Okay, plus capacitor. So clamper is the combination of diode, resistor and capacitor. Okay, so I'll show you here clamper. Okay, so this is the clamper guys, this is capacitor. Okay, so we have diode here, this is P part and this is N part. Okay, negative and positive and negative, right? And we have resistance which is parallel to diode, and then we have output, and this is input we can write Vm. Okay, so this is the clamper guide. This is a capacitor, this is diode, this is resistance. Okay, combination of capacitor, diode and resistance. Okay, and this is the V output, output voltage. Okay, so the work of clamper is that shifts the waveform. Okay, so now we'll analyze it. Okay, so we have this wave function. Okay, sinusoidal wave function. This one. Okay, so this is the wave function. So now we'll check the voltage, right? And then so this is the waveform we have, and we have to find the output waveform. Okay, so the first one, so first we are going to give for we'll give plus half cycle to this input. Okay, we are going to give plus half cycle. Okay, as we have done in papers. Okay, for plus half cycle, for plus half cycle. Okay, so means this one is the plus half cycle. This figure is going to be like this. We are giving plus Vm, okay, input voltage plus Vm. So this is the capacitor, okay, this is plus, this is minus, and capacitor voltage is Vc, let's say, okay. And then this is diode. So now we have given the positive cycle. For positive half cycle means V plus we have given, right, Vm plus. So here you can see this this plus and this plus, right, P. So this is this diode is in forward bias. Forward bias means it will work as a short circuited wire, right? So this is going to be like this, short circuited wire, and there is resistance R, and there is output voltage, V0, this one. So this is Vc and this is V0, guys. Now from here in this circuit, if we use KVL, so this is going to be Vm, this input voltage is Vm, guys, okay. Vm minus Vc, this is minus Vc, that is going to be equal to 0. So it means Vc is going to be Vm, Vc is going to be Vm, right? This is for plus half cycle. Now for minus half cycle, so for this V output, this is going to be, here we can see the output, here output is going to be V0 is going to be 0, because this is short circuited, means current will flow here, okay. So there is no current, right, means V0 is going to be 0, okay. And in loop Vc equal to Vm, right? So in that case, the output voltage for first half cycle, positive cycle, this is going to be like this, just a line 0, okay. This one, okay, this one. Next for minus half cycle, for minus half cycle, for minus half cycle, so for minus half cycle means we will give like this for this part, okay, this part. So again this is the diode, this one, capacitor will remain as it is. Now in this case you can see this one, in this case you can see here we are giving minus Vm, right, minus Vm for minus half cycle, minus Vm, okay. Just give me 1 second. Okay, minus Vm. So this circuit is going to be like this. This will be reverse bias, right, now, because this is minus part and this is plus part. So reverse bias means there is no current, right, here, and there is resistance, and there is the output. The output. Okay. So in that case, there is no current, right? And we'll take in this loop, okay. In this loop, this is going to be, this is Vc, right? So Vc minus, my apologies, it's Vm minus Vm, because we are giving minus Vm now for minus half cycle, right? So this is minus Vm, minus Vm. So this is going to be minus Vm minus Vc, this one, this loop, plus V output, minus V output, this will be minus V output, this one, minus V output, that is going to be 0 in this loop. Okay, so Vm minus Vc minus V out. Okay, so from here V output is going to be minus Vm minus Vc, and Vm is already we have found, that is Vm is equal to Vc. Vc value is Vm, right? So this is going to be minus Vm minus Vm, that is minus 2 Vm, right? Minus 2 Vm, minus 2 Vm, minus 2 Vm. So output voltage, output waveform is going to be, this is minus 2 Vm, guys. Okay, because this one minus Vc minus Vc, and this one minus V out, right? Minus 2 Vm means the output waveform is going to be like this, because here you can see the V is doubled, right? So it is output voltage is double of input voltage, right? So this is going to be like this. The output circuit is output waveform will be like this one, and then this one. This is 2 Vm, minus 2 Vm, minus 2 Vm. Okay, minus 2 Vm. So this will be the output. Okay, I hope you have understood it. Okay, so this one. This is the clamper, guys. Next question I'm going to solve. Next question is, so we have square wave output, okay, input, square waveform. Okay, I'll show you like this. This one is square waveform. Okay, this is minus 2 volt, minus 20 volt, and this value is, this is minus 20 volt, this is 20 volt. This is 20 volt, and this is minus 20 volt. Okay, this is the waveform, and we have been given this clamper. Clamper is like this. This one. This is capacitor, and there is a diode. This is the diode. Okay, and then this one. This is V0. Okay, so this is the clamper, and now for positive half cycle, we'll find for positive half cycle, this circuit page. Next page. So this is going to be like this. This is plus Vm, we have given positive half cycle. Okay, and this one. So for positive half cycle, you can see this is P part and this is positive, right? So this diode is forward bias. Forward bias means this will work as a short circuited wire. So this means this is just a short circuited wire, and this is the voltage. This one, okay. And then there is a resistance, and there is output, the output, and that is going to be, this is 10 volt, right? Okay, this is given, this is 10 volt. So here this is going to be 10 volt, means V0 is going, this is parallel, right? These are parallel, means V0 is 10, means here also V is 10, means V0 will be also 10 volt. Minus 10 volt, it's minus 10 volt, it's minus 10 volt, okay. So this is minus 10 volt output, and this is for first that for positive half cycle, right? And now in this loop we can use this KVL, okay, in this loop KVL. So this is going to be Vm, okay, Vm minus Vc, this is minus Vc, okay, and then this is plus 10, that is going to be equal to 0. So from here Vc is going to be 10 minus Vm, no, Vc is going to be 10 plus Vm, okay? 10 plus Vm. So Vc value is going to be 10 plus Vm value. We know that Vm value, this is input, right? 20 volt. Vm value is 20 volt. This one input, this is 20. So Vc value is 30 volt. So Vc. So there the Vc is 30 volt, right? Okay. Vc is 30 volt. 30 volt. Now for negative half cycle, for negative half cycle, for negative half cycle, this one, this is the capacitor, this one, this is minus Vm we have given, okay. And for negative half cycle you can see negative and positive, so this is going to be a reverse bias, means open circuited, right? So this is going to be like this. For negative half cycle, this is the capacitor, this is open circuited, okay, there is no current, and this is resistance, and this is output, okay. So in that case and V, this is V output, right? So in that case so we can use V output, right? V output means minus Vm minus Vc, this is plus minus, right? Vc, capacitor, minus Vc, and minus V0, that is going to be 0, right? So from here this is minus V0, right? Okay, and for it, yeah, minus V0. So from here V0 value is going to be minus Vm minus Vc, and Vm value, guys, we know that is minus 30 minus 20. Vm is minus 20, and question given, right, minus 20, and Vc is minus 30, we have already found minus 30. So this value is going to be minus 50 volt, minus 50 volt, okay. This is minus 50 volt, this is the V0, this is the V0 value, that is minus 50 volt, right? So in that case that V0 we have got minus 50 volt, okay, and also we have got this one, that Vc, that is 30 volt, okay. So output waveform is going to be like this. Because here V output, in this case we can see V output is positive half cycle, V output is minus 10 volt, right? And for and for negative half cycle V output is minus 50 volt, right? So then V output is going to be, so the output waveform is going to be like this. This is minus 10 volt. Okay, from here this will start and it will go like this. And this value is minus 50 volt. Okay, this is minus 10 volt and this is minus 50 volt. This is minus 50 volt. So you can see that it has shifted the waveform. Okay, there is a shift of the waveform. So initial waveform we have like this one, right? This one, and now after clamper, right, we've got this waveform. So that is shifted, right? So this is the one, guys. This one. Okay, next is voltage multiplier. Voltage multiplier. Voltage multiplier. Voltage multiplier. Okay, so we have this. We have capacitor C. Okay, and then we have one diode D1. This is D1. Okay, and then we have another diode, that is D2. Okay, and then this is the capacitor. It is R, and then there is output, V output. Okay, this is what we have. So this is voltage multiplier, guys, and here you can see these are capacitors C1 and C2. Okay, C1 and C2, and these are diode D1. So this is a voltage multiplier, right? So now we have to check. So we have this input voltage is like this, okay, sinusoidal wave. So now for positive half cycle, for positive half cycle, or positive half cycle, for positive half cycle, you can see for positive half cycle means we are going to give Vm plus, right? So plus means this is going to be forward biases. D1 is forward biases because it's P part, it's N part, right? Positive part we are getting, and this is going to be reverse bias, right? It means it is going to be open circuited. So the circuit is going to be like this. Plus Vm we have given. So this is the capacitor, and then this is forward bias. Forward bias means it will work as a short circuited wire, right? And then this is open circuited means this will be like this one, and then there is a capacitor. This is the capacitor. Okay, and then this is R, and this is output. V output. Okay, so here you can see, so it means there is no current flowing, right? It means V output is 0. Okay, V output is going to be 0. Okay, so from here in this loop we can get Vm minus Vc. This is Vc plus minus, right? Vm minus Vc, Vc equal to 0. So from here Vc value we have got, that is Vm. Vm and Vc value are equal. Now this is the one, and output is 0. Now for second is for negative half cycle. This is for positive half cycle. Negative half cycle. For negative half cycle, you can see negative half cycle, right? Negative half cycle means negative. Negative means this is going to be reverse bias. This is going to be forward bias, right? So the circuit is going to be like this. This is minus Vm this will be open circuited, right? It's a reverse bias, and this is forward bias. Minus minus forward bias means it will work as short circuited wire. Okay, and then this is this one. This will be this one. Okay, this is R, and then this is P naught. Okay, because this is open short circuited, and this is open circuited, right? This is C2. Now this is we have this one figure. Okay, so in that case we can use this loop equation in this circuit, V naught circuit, right? This one. So this is going to be minus Vm. This is minus this is plus minus, right? So this is minus Vm, and this is going to be minus Vc, Vc1. This is C1, and this sign you need to understand, guys. This is plus, this is minus and plus. Okay, minus plus, minus plus. Okay, so this is plus minus, plus minus. So this is going to be plus Vc2. This is important step. Okay, Vc2 equal to 0 in this circuit, in this loop. So from here Vc2 we can get it. Vc2 is going to be minus Vm minus Vc1, minus Vm minus Vcm. Minus Vm minus Vcm. Okay. So next for, so, and this we know, guys, this one we have Vc1 value we have already got, that is Vm. So minus 2 Vm. This is the value because Vc1 is Vm minus m, minus Vm we have got Vm, right? This one. So this is the value. So Vc2 we have got this value. This means Vc2 means this is Vc2. This is the same value as V naught, right? So it means V naught value is the same. V naught value is Vc2. Vc2 means V naught value is 2 Vm. Okay, V2 2 Vm. Any mistake we have done? This is minus, and we are cutting, so this value is plus, guys. Because Vc2 is going to be this will go this side, right? Plus 2 Vm. So V naught value is 2 V naught here. So here, right? Initially that is 0. This one 0, and this is V output is V naught. Means this is voltage doubler because it is doubling the voltage, right? So voltage doubler. You can say voltage doubler. Okay. Well, next question is, we have next question. Next question, that is, we have this one, guys. This one, and these are the output. Okay, so this is C1, C2 capacitors. So this is the circuit, guys, and so now for plus half cycle. Okay, for plus half cycle, this is going to be like this. For plus half cycle, this is forward wise, means this is going to work as this is going to work as that is short circuited wire, right? And this is going to be open circuited. Okay, because it is reverse bias, right? So the figure for positive half cycle figure is going to be like this. This is short circuited, and then this is output. This is C1, this is C2, C1 and C2. This one, this one. Okay, this is C1, C2. So because this is open circuited and this is short circuited, because we are giving for positive half cycle, right? That is plus PM we are giving positive half cycle. Okay, so in that case, positive half cycle. So here this is open circuited, means in this loop we'll use KVL. So it means VM minus VC1. VC1 voltage corresponding to this capacitor is VC1 equal to 0. So VC1 value is VM. Okay. Now for negative half cycle, we'll find for negative half cycle. For negative half cycle. For negative half cycle means you can see negative giving this is going to be reverse bias and this is going to be forward bias, right? So the figure is going to be like this. Minus VE, sorry, minus VM we have given. And this is forward bias. This is going to be reverse bias for minus. Okay. And here it is going to be this one. Okay. This one is positive, negative, positive, negative. Okay. So this is going to be the case. This is V output, right? So here you can see. So now we are going to use this. This is VM, right? So how we are going to use the loop, guys? You need to understand this. In this direction V1, because this is open circuited, right? And then this is going to be like this. Okay, in this way we are going to use the loop. Okay, so this is going to be minus VM minus VC2 minus VM. Okay, so we are going to use like this here, this one and this. So minus plus, this will be plus, right? Because we are using like this, right? This is minus plus. So plus V2, VC2 plus VC2. This is going to be, okay, so we have used like this. Okay, this is very important. Sign is important, 0. So from here, VC2 value is going to be VM, right? VM. And VC1 value we have already got, that is also VC1, right? So from here, V output voltage is going to be, V output is going to be this one, VC1 plus VC2, this plus this, right? So this is going to be VM plus VM, right? This is 2VM, this is 2VM, right? This is the V0, right? This is 2VM. So we have input voltage like this, right? It has double the output voltage, doubler, okay? Voltage multiplier. This becomes like this. So this was VM. So this is 2VM now. This is 2VM. This is 2VM. This is 2VM. And this is minus 2VM. Okay, so this is doubled, right? So this is the voltage multiplier. So voltage is doubled, output voltage is doubled. Okay, very good question, guys. This one, especially here, you need to understand how you are going to use loop equation here. Okay, so this is like this and then this. Okay, guys, I'm going to stop here. And also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, thank you so much. Bye now. And also, guys, I would like to request you, please share my lecture details to your friends, so that they will also be able to watch my free live lectures and will be benefited from it, guys. And this is my humble request to you guys. Okay, guys, so thank you so much. Bye now.